Evening, folks. Brian here, Geomagnetic Earth Watch. Thursday, September 17, 2025. So, folks, we need to delve deeper into the subject of the geomagnetic excursions, reversals, and the development of an unstable multipolar field to get a better grasp or understanding to where we are now and in what direction we're probably headed in. But also to know and to later on in this talk introduce the complication of grand solar minimums. So there's one thing I noticed on the internet. Everybody seems to have this limited understanding and jumps right into the conclusion of a pole flip or a magnetic field reversal without understanding the process and the length of time in between when things get started to the completion. But they're missing the middle part, the chaotic fractured field going through a period of multipolar magnetic fields, resulting in a multitude of wandering weak zones over our planet, such as happened during the last excursion approximately 41,000 years ago, called the Lachamps excursion, approximately 41,000 years ago, which lasted nearly 2,000 years, with a severely weak phase that lasted several hundred years, that phase in the middle, okay? So the current excursion happened at around 1903, 1904. It was last more or less stable. Nunavut, Canada. It spends its time touring around the northern Canada and Arctic, it just wanders about. Then around 1904, it started its beeline excursion, heading towards Siberia. Now, between 40,900 and 40,500 years ago was the peak radiation exposure, which also marked the final disappearance of Neanderthals in Europe. Our ancestors retreated to the protection of caves, then developed thick-skinned animal skin clothing and coated their exposed skin with like a mud clay-like substance. Aborigines in Australia, for example. They knew something was hitting their skin, like we're beginning to feel now, and they discovered it could have been by accident that when they coat their skin or it becomes coated, they get dirty with this mud substance, mud clay substance. Oh, they don't feel it anymore. During this transitional phase, with more of the highly energetic particles penetrating through the atmosphere, they change the chemistry of the atmosphere. Ionization increases productivity of the reactive nitrogen and hydrogen oxides. This is the process that deletes or thins out the protective ozone layer, which is supposed to be protecting us from the harmful ultraviolet radiation, especially during intense solar activity. The ozone layer thins or develops regional holes or penetrating UV through open or cracked magnetic field lines. So there would be regionally variable surges of ultraviolet radiation. Radiation also has dramatic consequences, changing the global atmospheric circulating patterns of jet streams. The weakening ozone layer changes the temperature gradient between polar regions and equatorial regions. It changes the wind patterns, such as we're beginning to see over the Americas, such as I show you quite a few times on the jet stream maps. And also creating climate instabilities and continental-wide shifts in weather patterns we can expect. Now the cosmic rays, the solar energetic particles uh, from the sun, this is what we hear most of the time. Have a solar event, a coronal hole opening or a CME, or those highly energetic particles. That's what we hear of most of the time. But there's also the galactic cosmic rays, which originate from outside our solar systems, the remnants from supernovas and so on. They are 10 times more energetic and potentially dangerous than the solar energetic particles from the sun. There's also a third source, Sal and Herculibus. But you think that's bad now? No, I'm not finished. Now we're going to get into grand solar minimum. Grand solar minimum is a 400-year cycle of our sun that goes into a period of low solar output activity. So basically there's 2 or 3 different cycles of the sun. There's the standard 11-year solar cycle. So it starts off at the bottom of the graph with minimal solar activity. It gradually increases to solar maximum where we are now, about 4.5 years later, and it stays up there for a couple of years. Then it begins its descent again back down to solar minimum again. So this is solar cycle number 25. We started in December 2019. We're now at solar maximum. Now we're about to descend into solar minimum. That's the 11-year solar cycle. Oh, but this is what most people fail to tell you. That's the average. In the past, there's been a couple of solar cycles that have been only 9 years. For all we know, we're up here, we can suddenly drop. So again, we have the 11-year solar cycle, the 400-year grand solar minimum cycle. That last one was called the Maunder minimum, which was 1645 to 1715, a period of very low solar activity. In fact, and this is measured by the number of sunspots. So during that period, normally there should have been 50,000 sunspots, but there were only 50 sunspots during the Maunder minimum. It also should be noted that during grand solar minimums and grand minima, the last one is the Dalton grand minima, 1790 to 1830. Now, during these periods is when we have our increase in catastrophic earthquakes and volcanic eruptions. Cascadia subduction zone, January 26, 1700, for example. During the Dalton minimum was the 2 New Madrid earthquakes. April 1815 was the Tambora volcanic eruption, and so on. So let me explain why. So Earth has its own magnetosphere, our magnetic field, which is supposed to be protecting us from the harmful cosmic radiation, which is destabilizing and weakening because of the geomagnetic excursion. The sun has something similar called the heliosphere. It's a big, huge bubble which envelops in our solar system and protects us from the galactic cosmic rays. However, during grand minima, solar minimum, and grand solar minimum, the sun's heliosphere shrinks upon itself, leaving us more exposed to the more highly energetic cosmic or galactic cosmic rays, 10 times more energetic than that which emanates from the sun. At the same time as we're going through the geomagnetic excursion, which is destabilizing and awakening our protective magnetic field. I'm not finished yet. The Lachamps event also included an extended, deep grand solar minimum period. So we should be beginning our descent at around 2027. We're not too sure. It's not acting as expected because there's an outside perturbance influencer. So we're supposed to be entering into grand solar minimum at the end of this cycle. Again, we started December 2019, so it should be normally completed around 2030. Okay, do you think it can get any worse? Of course it can. Don't forget there's Sal. Sal is lurking about, and something has been interacting with the backside of our sun, all those big, huge explosions we see. Sal, the binary companion, the evil twin star. By other names, Nibiru, Nemesis, Hercules. Yeah, I think that's about it. So I don't think there's anything else coming except for all those asteroids. So like I said, I see a lot of these videos being put out. Oh, we're going to have a pole flip. We're going to have a pole flip. And no one's realizing, covering, or talking about that transition period in between. The excursion starts. It can either go back or continue to a full reversal. But there's that period in between, which could be thousands of years. We only started in 2003, 2004. What's the hurry, people? So my focus and concentration, like I said, is the development of the multipolar field. Weak zones here and there, which is going to result in the penetration and more ultraviolet radiation coming in. It's only almost 12 minutes, so a couple of other points I want to raise. Folks, there's no such thing as the 6,000-year Earth disaster cycle. It does not exist. Perhaps every 12,000 years, yes, but nothing happened 6,000 years ago. If someone were to say that it's time for the next 6,000-year cycle, well, what happened during the last 6,000 year? Absolutely nothing. The only major shift was a shift between the nomadic hunter-gatherers to a settlement. They settled down and started agriculture settlements. That's the only major change that happened. A minor magnetic weakening in the China area, but there was no catastrophic changes on our planet 6,000 years ago. No one can show you that. You can do your own homework. Just like when I heard a long time ago, well, planet, you know what, or the destroyer of the crossing comes through every 3,600 years approximately. I've told you so many times, I do my homework and I check Earth's geological history, the ice core data from Antarctica to Greenland, to tree ring samples from that tree in New Zealand, and so on. And I kept on going back. I went back as far as 29,000 years, every single time. I can't find anything for 6,000 years ago, nothing. One more thing of interest. A while ago on the Paul Begley Comedy Hour, Thursday night Comedy Hour, this Mike from around the world said that, this was maybe 2 months ago now, that 3 asteroids would pass by Earth and then they would turn around and come back. Now, there was no need for him to be so cryptic and not explain. Well, I'll explain it. It's quite simple. Do you remember the Apollo 13 disaster when the onboard explosion of the oxygen tank and they had to find a way to get back to Earth pretty quickly? How did they do it? They used the moon's gravity, what's called a slingshot effect. They set a course for around the moon and used the moon's gravity to cause a slingshot to send the Apollo craft back to Earth. The same thing would happen for asteroids. If an asteroid approaches a large enough celestial body and gets caught by that gravitational force, it will either, one, keep it in orbit around that gravitational body, or 2, it will slingshot it back to its point of origin. So if an asteroids whiz past Earth and just miss, but there's something else out there waiting for it with a catcher's glove right here, right here. I'm going to catch you. I'm going to put you in orbit, and I'm going to slingshot you back down to your point of origin past Earth. That's what he was talking about. He was cryptically trying to say, well, the binary system's out there, and if we're going to have 3 asteroids pass by Earth, what's the news now? Then some force outside there, gravitational force, is going to capture them and slingshot them back towards Earth. Just something to think about. So like I said, I'm trying to stay on subject, focused on the development of a multipolar field, trying to anticipate based on observations where these weak areas are developing and what it means. I think one good indication is because of the chaotic behavior of the jet streams over the Americas. That's one area. And as I pointed out so many times, that is the opposite side of the planet of the 2 poles racing towards each other. The more you increase the distance between 2 ends of a bar magnet, the weaker the magnetic lines of force are. So as magnetic north racing towards Siberia, and magnetic south is not racing, it's moving a lot slower because something is preventing it from going any faster, cell coming up on the bottom. They're headed towards each other. And this is what everybody's talking about. Oh, they're headed towards each other. Bay of Bengal, relax, settle down. It could be another 2,000 years yet. It could be another 1,000 years. It is the process of developing a multiple magnetic field before then, which is a lot worse because it's an unknown. We don't know where, for how long, and how weak each area. Okay, folks. That's it for this one. My next talk is going to be on my membership channel because it's more controversial. I've done it once before. It's called The Missing Link. And we'll get it to in there, as you were.